3 variable regression, we have the dependent variable on the left hand side, and on the right hand side we have 2 independent variables or 2 explanatory variables. So a plus b2 x2 plus b3 x3 plus e. So we can put the suffixes here. So this is our regression model, and this represents the population regression function, that is PRF. Now for estimating a, beta 2 and beta 3, we have to apply the ordinary least square method. So for doing that, we have to find out v y hat I, that is equal to a hat plus b2 hat x2 I plus b3 hat x3 I. So this is our estimated yi hat. Now from here we can find out ui hat, which is equal to yi minus yi hat. That is the difference between the actual y and the estimated yi hat. So this we can write it as yi minus a hat minus b2 hat x2I minus b3 hat x3I. Now for doing the ordinary least square method, for applying the ordinary least square method, we have to consider the square of the error term, sum of the squares of the error term. So in that case, we have to calculate summation of ui hat square, which is equal to summation of yi minus a hat minus b2 hat x2I minus b3 hat x3I whole square. Now we have to estimate, we have to minimize this sum of ui hat square with respect to, we have to minimize this with respect to a hat, b2 hat and b3 hat. So in that case we will get 3 first order conditions. So we will get delta ui hat square, delta a hat, which is equal to 2 summation of yi minus a hat minus b2 hat x2I minus b3 hat x3I, and there is a negative sign here. So minus 1, that is equal to 0. So this is the first order condition. Then the second first order condition is delta summation ui hat square delta b2 hat is equal to 2 summation of yi minus a hat minus b2 hat x2I minus b3 hat x3I, and then we have to take the differentiation of this minus b2 hat x2I. So in that case we will get minus x2I within the summation term. So minus x2I. So that is equal to 0. And the third first order condition is summation of delta of ui hat square delta b3 hat is equal to, then again we will get 2 summation, then within bracket minus x3I, then yi minus a hat minus b2 hat x2I minus b3 hat x3 is equal to 0. So here we will get 3 first order conditions for getting the value of a hat, b2 hat and b3 hat. Now these 3 equations, now these 3 first order conditions are called normal equations in ordinary least square method. Now if we solve these 3 equations, then we will get the values of a hat, b2 hat and b3 hat. Now after working with these 3 equations, we will get b2 hat summation of x2 square plus b3 hat summation of x2 x3 is equal to summation of x2 y. And the second equation that we will get is b2 hat summation of x2 x3 plus b3 hat summation of x3 square is equal to summation of x3. So after solving, after simplifying those three normal equations, we will get these two equations. Now here all these x and all these y are in deviation form. That is, we are considering the small x and small y. So capital X2 minus x bar is small x2, y minus y bar, capital Y minus y bar is small y, and capital X3 minus x3 bar is equal to small x. So here we are considering all the x and y's in deviation forms. That is, we are considering the small x and y's. Now if we apply the Cramer's rule here, then we can get the beta 2 hat and beta 3 hat. So beta 2 hat is equal to, in the numerator, the determinant of x2y, x3y, then we have summation of x2 x3 and summation of x3 square, and in the denominator we will get summation of x2 square, summation of x2 x3, then summation of x2 x3, then summation of x3 square. So if we solve this, then we will get the value of beta 2 hat, and similarly we can get the value of beta 3 hat by applying the Cramer's rule. So the value of beta 3 hat will be equal to the determinant of x2y, x3y, then the determinant of x2 square, x2 x3, then in place of these two term we will get x2y and x3, summation of x2y, x3y in the numerator, and in the denominator we will consider the original determinant on the left hand side. So then we can get the value of beta 3